All right, here we go. We're going to do some problems using a differentiating some problems involving some trig and chain rule. First here, what we have is sine of x times cotangent of x. We'll call this function f of x. All right, so first off, what we can do is students, when they see this one, they're going to use the product rule. Now, one thing I would advise is whenever you have trig, see if you can simplify it. Cotangent actually is cosine of x over sine of x. All right, cancel, left with cosine. So we can take the derivative of this and actually just get sine of x, and there's our function. That's a derivative. So pretty simple. Another one, so simplifying, that's one key. Oops. Let's say we have this, and I'm following on the worksheet, but for all those that don't care or don't have the worksheet, but basically there's just a bunch of problems involving trig and chain rule and a bunch of other things. So find the derivative of this function. So we want to find g prime. And what we have right here is 1 plus secant of w over 1 minus secant of w. And we're going to use the quotient rule. Hopefully you're thinking in your heads, I want to use the quotient rule. That was weird, but that's okay. So we're going to take the derivative at the top. We're going to take the derivative of 1 plus secant of w, which is going to give us secant w tangent w, times the bottom, or the denominator, 1 minus secant w, minus the derivative of the bottom, which is negative secant w tangent w. So I can make that plus. Secant w, and then multiply by the top, which is 1 plus secant of w, all over the bottom of w, the quantity squared. All right, I'm going to simplify it, but just for time's sake and whatnot, we'll just leave it like it is. We could probably take this and make it this positive. Eliminate that, and we can get our answer. Now, we'll continue on. Let's try some more. Let's say we have number 6 right here. I assigned all the multiple of 3. So, if you're wondering how we're going about this, we have f prime, and we're going to use the chain rule. We have our outside function, which is cosine of u. We have u, which equals 4 minus 3t. So we're going to take this with respect to t, differentiate this. So we're going to take the derivative of cosine, which is negative sine of u. U is 4 minus 3t. Make sure you plug that in there. Times now the derivative of u here, which is going to give us negative 3. So we could rewrite this as negative makes it positive, so 3 sine of 4 minus 3t. Now, a lot of people in my class have a problem with this because whenever they see a problem like this, sometimes they don't know their trig very well, and they think it's cosine times 4 minus 3t and use the product rule. That is incorrect, and actually that will give you an answer that is wrong, not once, but all the time. So don't ever do that. This is cosine of, of 4 minus 3t. All right, well, let's continue on. We'll go to number 9 here, a little more room. And what we have here is tz, that's kind of fun to say, secant of 2z plus 1, that quantity squared. All right, now, we're going to find t prime. I think this is with respect to z. Now, this square is inside secant. So our outside function, we're going to use chain rule again, is secant. So we're going to take the derivative of secant, which is secant tangent. Now, secant, our inside function, is 2z plus 1, that quantity squared. So we have 2z plus 1, that quantity squared. Now, after we have that, we now go to the outside, or look at this function. That function is going to be, take that derivative, we're going to use the chain rule again. So now we have the outside function, which is 2, or u squared. So it'll be 2u, u being 2z plus 1, the first, times the derivative of the inside of that. So what's the derivative of that function? Which is 2. And that's why they call it chain rule. Keep on multiplying the derivative of the outside times the inside derivative of that, and so on and so forth. We can simplify this. We have 2 times 2, which is 4. 4, we can bring the 2z plus 1 in front, if you wish, And then we can have our secant of 2z plus 1, that quantity squared, tangent of 2z plus 1, that quantity squared, and that would be our answer. All right, moving on. Number 12. 12, we have f of x equals tangent of 2x squared plus 3. F prime, and once again, chain rule. Outside function, and if you're wondering, yes, I'm being a little inconsistent. Sometimes I write it out, sometimes I don't. U in this case is 2x squared plus 3. Okay? So we're going to take the derivative of the outside, which is going to be secant squared of u. U is 2x squared plus 3. Times now the derivative of the inside of u. So we're going to take u prime. All right, that's u prime. And that's going to give us 4x. And that's our derivative. All right, moving on. We have f t equals cosecant squared of 2t. Now, be careful. This is cosecant squared of 2t, which is not cosine, sorry, which is actually cosecant of 2t, that quantity squared. So when you have this, our outside function is u squared. Our inside function is cosecant of 2x. So when we take the derivative of this with respect to x, we're going to take the derivative of the outside, which would be 2u, which is cosecant of 2x first, times now the derivative of cosecant, because now we have to take the derivative of u. Derivative of u, and we're going to use the chain rule again, so this is a double chain rule. Cosecant is negative cosecant of our inside, which is 2x, times cotangent of our inside, which is 2x, times now the derivative of that inside, which is 2x, and that's where we get to 2. And that's our answer. To simplify it, we have 2 times a negative, so we have negative 4. We have cosecant times cosecant, so we have cosecant squared of 2x, cotangent of 2x, and that's our derivative. Hopefully this going through these different type of problems is really helping you out. All right, we have another problem. We have h of x equals x times cosecant of x squared. Okay. H prime. This one we're going to have to use the product rule. Product rule. All right, we're using the product rule. Now with the product rule, we're going to take the derivative of the first, which is x, so we have 1, times the second function, plus now the derivative of the second. Now the second, this is where we're going to use the chain rule. Our outside function is cosecant, so the derivative of cosecant is negative cosecant, now remember keep the inside in there, x squared times cotangent of x squared, times now the derivative of that inside, which is x squared. And we don't have to do it once, because that's our star inside, that's our input, so we just have 2x. And that right there is a derivative of cosecant of x squared. And then don't forget to finish off your product rule by multiplying by the first. I almost forgot it, actually. All right, so we multiply by x. So that x comes from this x is actually that x right there, finishing the product rule. Want to simplify, we can have cosecant of x squared minus, multiply those two, we got negative 2x squared, cosecant of x squared, cotangent of x squared, and we're happy. All right, and that's a little simplified answer. Still simplify it farther, but we'll just leave it like that. And we'll do one more. And what we have here is number 21. In number 21, we have n of x equals sine of 5x minus cosine of 5x to the fifth. All right, using the chain rule to find this derivative. Our outside function, hopefully you see, is u to the fifth, so it'd be 5. U is sine of 5x minus cosine of 5x. The u, whenever I say that, is the inside function. times now the derivative of the inside. So take the derivative of sine 5x. This is a common one that you have to know how to do. Another chain rule. Derivative of sine is cosine of 5x times 5. For the inside, so times 5. Minus now the derivative of cosine, which is negative sine of 5x, times that inside, which is 5. And when we have right here, we can simplify. 5 sine of 5x minus cosine of 5x is the fourth. Put the 5 in front there. Cosine of 5x, positive 5 sine of 5x. And there we have it. All right. Did several additional problems of using the chain rule and trig. Hope this helps you out. And God bless and your rest of your calculus adventures.